Last time I didn't have any audio. Very cool. I should have audio now. OBS is saying I've got audio, so that's good. Oh, this is so confusing. Oh, my brain. Is that working? How do I tell if it's working? How do you do anything with this? Is anything working? That is the question. Oh, the lag. Oh, yes. Oh, gosh. No. Does anyone chat? No. I lost my views because I didn't plug in a microphone. I was like, oh, do I want to wear headphones? Not really, I won't wear headphones. I forgot about the fact that everything really. Slow internet moment. I guess I just have to sit and wait for the start. Does anyone chat? Please put something, just so I can find something to talk about. Lol. And this is why I don't usually live stream. It's just so much effort to edit is the problem. Ah, yes. Oh my goodness. The internet. Oh, it's me. It's also me. Oh my goodness, I have viewers. Yes. I just don't have a chat box. That's very cool. Yo, welcome, Kaiser. Yeah. What's your favourite topic in maths, Kazan? There we go. Viewer interaction doing a thing. Oh, I was shaking my head. I should have just speedrunning Super Mario 64 DS. I knew doing something more adventurous was a bad idea. Just explaining why I had no microphone, because I'm a bad streamer. Oh my goodness, I need to do something before my viewers just leave because there's nothing happening. There we go, viewer interaction doing a thing. Right, so I posted that on the Discord. I should have speedrunning Super Mario 64 DS. What else do I need to do? I knew doing something more adventurous was a bad idea. Yes. I can do stuff. And then have I got stream on there? Oh my god. Yes, there we go. Alright, let's do this. Give the viewers what they came for. Okay, so we're doing binomial expansion. So what is binomial expansion? I don't know. Let's think through it. So basically, as part of binomial expansion, we have arithmetic. Oh yes, and we have computations. And basically, where it gets useful is with arithmetic, but in order to do arithmetic with binomial expansions, you need to learn what the computations are. Before we can do any of this, we sort of need to know what is binomial expansion itself. So what it is basically where you have a plus b to the power of n. Here you got your binomial expression, and when you expand it, it's binomial expansion. Oh my goodness, maths is difficult. Bro, I should just play Bed Wars. Have I got anyone in chat? No. Seems legit. I started the stream without a microphone. Big mistake. The bigger mistake was doing a math stream in the first place, but that's okay. I didn't realize how hard it would be to write anything. Like even, let's just write up something. Why is it lagging? I've barely got anything happening. Like even if I wanted to do some simple stuff. Oh, it's working fine now. I don't know. Seems to be working fine. I don't know. All right. Let's just put that over there for now. Boop. Okay. So I guess I'll just write stuff out. Will I? Oh, I can play Chuckie. Oh my goodness, this jump is hot. Ugh. Well, oh, no views. That's fair. And we'll just ditch that there. Yes. I know, but now I'm clickbaiting all the viewers into thinking they're going to get actual game. Like, how loud is that for viewers? There we go. Discord's taking about 7 years. Still too loud. Why is Chuckie's the loudest thing ever? No, confused viewers. Ugh. Oh, everything's taking a million years to load. There we go. Okay. Yeah, I was gonna do a a stream on binomial expansions because I was like, oh yeah, making easy. Oh, it's like game over. Because I was like, oh yeah, making easy maps videos, that won't be too hard. Well, like not easy maps videos, but as in like the maps itself isn't too difficult. So I was like, oh yeah, and I can make that engaging and fun. I won't get bored in 2 seconds. Hello. Oh, it's Zane. What? Look out my window. I'm so scared. That's not fun when you get that as a message. Wait, I need to see what this is. I'm so confused. Zane, you're scaring and confusing me. There's nothing there. What is this? I'm scared. Have I been identity tracked? I don't know. But welcome to the stream, Zane. How are you? Oh no, how long ago was that? Oh, sad times. It's probably a while ago. But yeah, I was like, oh yeah, mouse stream will be fine, but no. I guess presenting is just really, really difficult. And on the fly presenting is impossible, I guess. So that's pretty sad. Guess I'll have to get a real job. Oh no. I'm definitely going to try and find a way to try again. I'm just not exactly sure how. Why is this game so good? The thing is, when you like delve into this game, like in terms of the what's going on, it's really simple. Like the physics and everything, but it's so fun to... Oh my goodness, I have no idea how someone could make something this fun that's got this little to it. Jumping onto these platforms hard though. Oh yes, epic gamer. Ah. Also, Aaron, are you in the stream? You should join. I should ask Aaron to join the stream. Oh my goodness. Am I still webcamming? I am, although I'm sitting way too close to the camera for webcamming. Okay, good to know. There we go. But now the gameplay. Oh, I should make the gameplay bigger. See, garbage streamer. Oh my goodness, did that mess up? Yeah, there we go. I have to remember webcamming, how it works and stuff. Oh no, that's bad. Oh, and I'm dead. Oh, level 3 max, garbage gamer. We're gonna start from level 2 because repetition bad. Oh no, we should go straight to like, yeah. This is not a level that I can complete. Oh well. It's better game playing the same thing over and over. This is my demise. Oh. Wait, you can actually make that jump? I'm so lucky that bird went down. Platform co! Oh my goodness. Okay. And, oh, it's not even game over yet, no. This was a mistake. Oh, the skills, nope. And, okay. Epic. Okay, let's just go level 2. Oh, the interface. Oh yes, there we go. Oh, I'm being advertised. There's nothing I can do about that. It's funny with games like this, at first you're like, oh yeah, there's no way this is ever going to be a mainstream thing. But then stuff like Minecraft, like even after everyone was like, oh yeah, there's no way that's going to be mainstream, becomes mainstream. And then recently Among Us became mainstream. And like no one thought that would happen. So it seems to be a thing where people are just playing like the most random game But like, imagine if this was the next one. Oh my goodness. Maybe. That'd be funny. Just the most garbage game ever, but then everyone's just playing. Oh, no, that's not. This game's actually amazing though. I'm gonna fall down. I did not fall down. What the heck? Yeah. Oh yeah, I made it past level 3. Nope. So waiting for someone to just join and be like so confused. Oh. This game might actually be pretty fun with better physics. I'm considering, because for some reason I'm in an opportunity where I get to develop whatever as a video game for a client. I don't know why, but that's a thing. I'm definitely considering trying to remake Chuckie. I don't know what programming language to use though. I'm thinking C++, but I don't even know. There's no one in chat to suggest anything different. Sad times. Do 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 do. I want the egg. Yes. How are you meant to get that egg there? Is there a strat? Can I make that big jump? Let's find out. Nope. There. Let's do that. Seeing as my confused expressions aren't adding anything to the video. I mean, maybe, but not much. Oh, that's fun. Hey guys, welcome back to another episode of Glitch Breakers. Oh, that's cool. And then I phased for an egg. What other games have eggs in them? That's a question. I think that worked. I did it. Yeah. That's level. Level 6, 0 lives. Oh, it's this one. I know this one. Please don't go this way. Okay, I actually got away with that. No, what am I? Okay. 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 Nope. Level 6. Let's just go back there. How did I make that? I'm actually ninja. Ninja gamer. Ninja gamer as opposed to just being ninja. I don't think being ninja is something you want to be at this point. I don't know. I mean, he has Fortnite skills. What more could you want there? I don't know. Oh, he's going to come this way, isn't he? Okay. It's annoying because to make difficulty, they removed like all the ideas of like flow and stuff, which is honestly what makes gaming. I don't know. Oh no. Oh my goodness. Imagine this game multiplayer though. That is the goal, by the way. It won't be online multiplayer though, because web servers, unless I can find a way to learn about them. Oh no. Well, at least I got the egg while I fell off. Better than nothing. Gosh, this level's a real grind. The heck? Okay. Whoa, okay. That's a new one. Oh, I feel like there's an instant jump strat there. You can make that? No. No. Okay, I'll just sit out here. Oh. Oh. No. All that work. It's okay. I would suggest playing Repton, but oh my goodness, Repton's so bad. You know what? In a bit, we're doing it. Full explorer of this site, reptonfree.co.uk. Oh my goodness. Okay. You know, there's levels, but then if I reload, then there's the chances of it. I'm not going to reload. Oh. Oh boy. Part of me still wants to do the maths. Thing is, how low allowed? There's no way of me knowing how low allowed. Oh well, quiet the audio is sometimes. Problem is, making maths engaging hard. How did that work out for me? Oh, what? Why does that work? It should not work. Nothing about this game should work. It just doesn't make sense. It really doesn't. Really doesn't. Okay, let's find a bird level. 7. No. No, not a bird level. I have to play. Well, I am clever. What the heck? How many eggs? What happens if I refresh? Please don't take a million years to load. Oh my goodness, it didn't. So we've done level 8? We have, that's level 8. Okay. Alright, well level 9 I guess. Yes! Oh my goodness, this is where Chuckie Egg becomes a game. As opposed to... I don't know. Okay. No, 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 no. I'm so not... The plays! Oh my goodness. Let's go. There's so much potential in this game for epic gamer strats. Is what makes this game a thing, really. How? How? You meant to even... Okay, I figured it out. Go! Go! Go, Pac-Man! Oh! No! I went for the super clip strat. Oh, you bird. Okay. Oh my goodness, I made it to an... Oh, yeah. Go, go. Oh, just go. No. Just go. The fact you can make it up there before the bird wakes up. Oh my goodness. Yes. What's this level? Answer hot garbage. Oh my goodness. I don't know where to go. Ideally not there. I got checkmated, basically. Okay, well that's the thing. Oh no, okay. Okay. Well, that was a fun run of thing. We're doing it. Fine. No, this isn't, is it? No. Oh my goodness. Where's the first one? There's the first one. Oh, yes. The best, worst video game of all time. Let's do it. We need to put the volume up for this game. I didn't start. Okay. No, why doesn't it start? Don't do it. No. They broke Rapton? No. No. The tension. Oh my. Guys, they broke Rapton. No. Oh my goodness. It worked. Oh, I'm so glad. I was worried. I thought it was gone. We need this video game. We need this in our lives. Oh my days. Let's go. The game where the mechanics make less than 0 sense. And the sound effects are on point. Okay. Why do I feel like that rock is just determined to move? Is it a rock? No one really knows. You can call anything anything here. That's how nonsensical the mechanics are. I'm gonna call it... What am I gonna call it? Don't know. Looks like some kind of sugary thing. I don't know. Oh yeah, and the soundtrack for this game, oh my goodness, on point. What's going on over here? Death. Okay. Oh my goodness, this game makes you so nervous about whether or not you've got everything or not. Okay. And we're trapped in here, yeah. Not falling for the old... I don't know. This game seems both genius and awful at the same time. It is pretty interesting. It's going to be a point where I'm not sure which one I have or haven't collected. Oh, and his walking forwards animation and walking backwards. But it's okay because it just looks like he's having a dance and it's great. Okay. What do I still get? Oh, and by the way, level 2 makes even less sense than this level. Have I ever beaten level 2? Oh, I'm locked in. Well, it's just as well I let myself out through here at the start. Oh no, where's the last star? Oh no. It's down here. Do I really want to know? No, not really. Well, there's no way to get there. Eh? Am I nearly done? Oh my goodness. I should beat a level. Oh no. Do I even want to look? Oh no. Like, just no. Like, imagine actually trying to this level. First one's like, oh yeah, I get what's going on here, and then this level is like, oh. Well, that was wrapped on. This stream is getting so not normal. Speedrun time. I don't have enough time to finish speedrun. Let's do it. It's 30 minutes or so. That's pretty sad. Oh my goodness, Aaron actually joined the stream. Aaron, what do I do? Wait, do you want to play Bed Wars? Join the voice call. I was just playing Chuckie again, it was great. Oh, actually, you should 1v1 me at Chuckie again, Aaron. We'll figure out a system and 1v1 me. Are you busy with stuff? You're probably busy with stuff. Why would you have time free? No one has time free. Even though Corona's closing everything, so you'd think everyone has time free, but no. Everyone's still busy. Sad times. But how are you anyway? Are you alive? Don't know. Oh, whoever my viewer was is gone. Sad times. I sure as people can't see my screen. Oh well. Complete BBC Micro Games Archive is now bigger than the actual game site for Chuckie. That doesn't make any sense. just math homework. Oh, it's loaded. Oh no. Done bad things. Does that mute the mic? Does that mute it for here? It doesn't. How very cool. Also, I have no idea what I'm doing. You're here. Yeah, I agree. Oh my goodness. Yeah, I'm playing the best video game ever, definitely. You should 1v1 me at this. Maybe, I don't know. I wasn't gonna do a math stream, but then yeah, I know. I was, and then it was like, no. I realized that talking about math hard, because math hard, basically. Everything's hard. Doing anything worthwhile is just impossible, basically. Yo. Like, this is maths. We're looking at the geometry here and the game physics of the math program. So as you can see, the programmer didn't code an acceleration during the day in the air. So when you start jumping, like your trajectory, disliking the video. Yeah, that's fair. Worst video ever. No, but this is the best video game ever. You should join me at this. We'll have a race versus level 5 from the beginning. This is just called Chuckie Egg, and that's like the third link down. Oh, I'm so dead. Okay. No, it's over. It's not. It's over. Oh my goodness. Oh my goodness. Chat, it's actually real. Keep going, points gun to head. I don't understand what that means. Not as good as maths. Oh, why do you want actual maths? Alright. Blame Avia, we're unironically doing maths, let's do it. Alright. Let's do this. Oh my goodness. Alright. So... Okay, so this is a binomial expansion, guys. It looks like this. Oh gosh. There we go, we've invented a new letter. Oh wait, that's just the letter D. Never mind. And for this expansion, we have n+1 terms, and we can index these terms with 0, then 1, and 2, and 3, all the way up to n. Only we tend to label these R, because we do. Even the nth one we label the rth term. Yeah. And the rth term has a formula that you need to know, just because you like binomial expansions for some reason. And you're like, oh yeah, I need to expand some binomials. And you're like, well, I could do it manually, but like, nah, save time. So, you can use this formula, which represents the rth term of the expansion, which can be given by the index. So for the first term, we'll have an index of 0, which means a value of r. For the first term, we'll have a value of r as 1. For the third term, we'll have a value of 2, etc. All the way up to the final term, which will just be equal to n, whatever n is. And then this part of the formula is just a to the power of r. And you might be wondering, the heck is this thing? I mean, it's clear what these two things are, because these are just... This is just this. Oh, I switched letter. Oh well. I've used colours, so it all makes sense. And this is linked to this, but it's like, well, what's this? This is what I like to call the cool function. What the cool function does, it takes in two inputs, n and r, which will be values when we actually do one, a binomial expansion in a second, seeing as I'm actually into this math somehow now. Oh my goodness, I have viewers now? Or I just need to do maths and I get viewers? Oh my goodness. I don't understand. Alright, the formula's like this. So we've got n factorial over r factorial. I should turn on my webcam. There we go. N minus r factorial. But the thing is, you don't actually need to... Sometimes you need to use this. I'll explain when you would and when you wouldn't need to use this. So for the most part, you don't need to use this because all of this is on your calculator. So you actually have there's no way it's going to show on the camera. Oh, it might do, but it's all inverted. But anyway, there's a button on your calculator. I'll draw it. It looks like this. And it'll let you type the n value here and the r value over here. So you can do this function all within your calculator rather than having to actually type out the number factorial over the other number factorial, then this number minus that number factorial. So that's pretty cool. Alright, we should probably actually do one so it actually makes sense, kind of, maybe. I mean, maths making sense, really, maybe? I don't know, we'll see. Okay, that's big. Oh, drag it down there. Alright, let's do one. I need some numbers. I'll just think some numbers. Let's do... Why is that so thick? Okay, let's do that. 2 plus 3y to the third power. Oh. Alright, so as I said before, the number of terms is going to be, there's going to be n number of terms because we go index, no, n plus 1 terms because we start with 0, which is our extra one, and we just go for it. So in this case, we'll have our 0th term, first term, second term, fourth term. Yeah, because we've got 4 terms, the index like that, so the final index will be our n value, which is 3. Let's write that here. Okay. Okay, and we've got our formula over there. This is important. Okay, so how do we do a thing? It's a good question. Oh gosh. If I zoom out, it'll be, oh, well, it'll mess up what I've done there, but it's fine. Okay, so for our 0th term, we've got an r value of 0, n value of whatever n value is, which is not 1, it's 3. So we'll do, for our 0th term, we'll have 3c 0 n minus r0 n's 3, so that's just, oh no, it's not b because we've got a b value now, which is 2 to the power of 3, and then r, which is just 0, so that's just 3y to the power of 0, which is just 1. And oh yeah, there's a few different ways we can define this function actually. It's so cool it has multiple ways. The NCR one, so we can do it relative to this factorial mess, but what I would say is probably the coolest way to define it is relative to the Pascal's triangle, which is pretty lit, not gonna lie. So this is Pascal's triangle. It's pretty cool. It pops up a lot in combinatorics for no reason at all. And for some reason, binomial expansion. Things in maths just link, and you're like, why the heck do these even link? But they do. So we have our terms like this. It just so happens n and r directly relate to this. So this is n equals 0 row. This is the n equals 1 row. This is the n equals 2 row, etc. And within each row we have r values. So this will be r0, this will be r0, r1, etc. So here, because we're asking for 3c0, what we do is we go to the third row of Pascal's triangle, which is here, and we look up the 0th term, the 0th item of the third row, because we've got an r value of 0 here. So 3c0 is actually just 1. You can put it in your calculator to check and stuff. It's pretty cool. Thanks, Aaron. So 3z0, so let's go with another color again. So we go to the third row because 3 and 0, so it's here. So we put in a 1. I'd say that's probably the nicest way to use this formula. Pascal's triangle is amazing. Our teacher was like, no, I hate Pascal's triangle. It's actually kind of sick. Okay, so we got 1 times by 2 cubed, that gives 8, times a 3 to the power of y, so that's just 8. So our first term of the expansion is 8. Alright, let's try and go quicker for the next one now. We've got our computations in place. So next one, again, I should copy and paste. I can do anything. I'm on a computer. Computers are powerful. He says, yes, kind of. Yeah, it worked. Okay. And this is why computer science exists. Okay, so for our second one, we've got an R value of 1. So we've got 3C1, R2, so that's just n minus R. So because R is increased by 1, our power is decreasing by 1 because we're doing minus R. So for this one, we'll have 2 to the power of 2. And then here, because it's R, that means we're increasing each time because R increases each time as we go across. So we've got 3y to the power of 1. To find out what 3C1 is, we just go to Pascal's triangle. Let's go with another color, or hot pink. And we're going to go here because we've got RC1 this time. So we go to the first one because this is the 0th one, that's the first one. So we're going to have a value of 3 for this. Boop. 2 cubed is just 2 squared, sorry, just 4. 3y. Can multiply those out. 9 times 4, 36. 36y. Bada bing, bada boom. Next term. Alright, we're getting quicker here. Right, before we even do anything, we know it's going to be 3c2. We can just look at the next one. So it's going to be 3. Then we're going to decrease by 1 because of this formula. So we're going to have 2. And then we're going to have this increased by 1 because r increases each time. So we've got 3 squared y squared because we're going to do 3y squared. So that'll square each of the two factors of 3y. Then we're going to have 3 squared by 3, that's 27 by 2, 27 by 2, 54y squared. Or, picking up the pace here, guys, exciting. We're nearly finished this expansion, what the heck? Bro, this went from a joke to actually being something, oh my goodness. Alright, one more term, guys. Oh my gosh. Right, 3c3, that's going to be our third one there, it's just a 1. Then, what was it last time? It was 2 last time. It's going down. The index is 3, so that's going to be n, which is 3 minus 3, 0. So instead of having 2 to the power of something, well, we will, it'll be 2 to the power of 0, but that's just 1. So we can write another 1. And then what about the final one? Oh yeah, 3y cubed, so that's going to be 3 cubed y cubed. 3 cubed is just 27, so we've got 27y cubed. There we go, that's binomial expansion. Whoa. And now you can go destroy some equations. So gamer. Oh my goodness. So yeah. That was my lecture. Please subscribe to my YouTube channel. Oh my goodness. What else is there still to explore here? We actually did a lot of decent math. Oh my gosh. What? Bro, why didn't I just do this from the start? This is way better than Chuckie Egg. I kind of out of ideas though. Pretty much covered everything. Dang. Lost my pace and everything because I think that's it. Oh yeah, we could go back and talk about this. We can talk about this. So after introducing this, I pretty much just neglected it and didn't look at it the whole time. Reason being, Pascal's triangle is basically amazing for everything, except not everything, but most things. It's pretty fancy. You don't have to use it because you could have used this formula the whole time. It's messy and just looking at the triangle is way more fun. So that's what we did. But sometimes this is important. So let's imagine that for some reason you're locked in a room and you have to solve a maths question to get out. I don't know. Not realistic. Maths isn't realistic, but whatever. Can be sometimes, but not very often. Depends if you're a computer scientist, really. No, not a joke. Like I learned linear algebra. I was like, oh, there's no way this is ever going to be useful. And then I was programming one time and ended up being so useful, it was crazy. My brain actually exploded. Alright, so let's say we were told that 3c n equals 2c n. This is not going to work, is it? Let's do an example that I've actually seen, because I know it will work. Alright, let's say. Oh, I need to choose another letter other than n. What's the other letter we could use? Oh, let's use x because it looks mathematical. There we go. Equals ncx plus... I should check this question works before I do it. Yes. Yes. Yes, let's do that. Yeah, that should work. Okay. And let's say the question asked you to link. Okay, this is actually quite hard, but let's do it, maybe. I don't know. This will be a true test of viewer participation skills, I guess. Okay, so we've got to link n and k. So we can't just plug these numbers into the calculator. and we can't just plug it into Pascal's triangle because they're unknown values. So the only way to solve this is to be aware of the fact that it can also equal this disgusting mess. So let's do that. So nc to the power of x, that's just going to be the n value factorial, which is just n here, so n factorial, over r factorial, which is just x, and then n minus x factorial. What's going on the other side? It's a good question. Let's find out. Pretty similar things going on here. Oh no, is it -1? It's not. That works? Apparently it works. I want to see this working. I mean, looking at this, okay, I'll write it out and then I'll explain why it doesn't look like it should work. It doesn't look like it should work at all, but I think it will. I don't know, we'll find out. Yeah. Oh, so it's x plus 1, so that's n minus x minus 1, because x plus 1 times by -1 gives minus x minus 1. All factorial. Okay, so the big question here is what can we do next? I mean, we've got two fractions that we know are equal to each other, so we could cross multiply, which is pretty fun, which is where you just go boop, boop, and you basically just do two steps at once. You multiply this, you multiply by this on this side and this on this side to get it. No fractions. So let's do that, just because it seems fun. And if it seems fun, it's probably going to be rewarding in mathematics. I have no idea why either. It looks kind of messy, but there's probably, after we've done this, some steps we can do that aren't immediately obvious. I hope. Nope, I'm doing bad things, because this is meant to come from there, so it's going to be minus x minus 1. Factorial. And then on this side, it's going to be, what's it going to be? It's going to be similar, like that, and that's just be n minus x instead. Okay. And already we've actually revealed some steps that weren't immediately obvious from before. So what becomes a lot clearer now is that, let's get the green, is that we've got these on this side, and we've also got these on this side. And we know with factorial, you can only do factorial with positive numbers. So we know these are going to be positive. And most importantly, we know they're not going to be 0, because even if it was 0, 0 factorial equals 1. I might even get into why 0 factorial equals 1, unless everyone knows that, in which case I won't, because then it's irrelevant. But because of that, it means we know we can divide by these unknowns on each side, because we know they won't be 0. If you divide by 0, bad things happen, but we know they're not 0 for sure, so it's more than acceptable to just go, boop, simplification. So we got n minus x minus 1 factorial on this side, and n minus x factorial on this side. Alright, and now we can do a fun thing. So, this seems so unorthodox and like you shouldn't be able to do it, but we really can, and it's going to be great. Oh, you can barely read it on this side. This doesn't seem right. What have I done wrong? Oh no, I figured out what I've done wrong. I've done a bad thing. This is x minus 1 because of this. No. My whole career. I'm just kidding, it's fine. We can just autocorrect here. So it's x minus 1, so that means we couldn't cancel the x factorial, and we did. But that's okay, because not much has happened, so it'll be fine. Why am I doing k? It's x. Oh well, I'll just pretend that's an x. So this is actually x minus 1 factorial. Very cool. Equals x factorial. I promise this is solvable. It doesn't look like it is, but it is. Okay. So what we can do is because this is n minus x factorial, we know it will actually like it's actually going to be the number. So factorial means the number times the number minus 1 times the number minus 2 times the number minus 3, etc. Okay, thanks. So here we know that it's going to be the number, which is n minus x, because it's factorial, we know it'll be times by n minus x minus 1 factorial. And this seems like ridiculous, like what? How can you split it into that? But then when you think about it, it kind of makes sense, because factorial just means continue doing this process of splitting it up. But then because we've now got this, which I'll do in blue, we've actually got this on the other side here. So we can literally just cancel there. We've like created that and cancel it. We haven't created anything, we just rearranged it. But it feels like we created something, but we haven't, so that's pretty cool. So now we've got x minus, this is minus n, isn't it? No, minus 1. Why is it minus 1? No, it's not, it's plus, because it was plus before. Okay. X plus 1 factorial, because we've cancelled these, equals x factorial, and now it's just n minus x, no factorial, because we split it up into n minus x minus 1 factorial. Okay, so what's left to do? Not a lot, because here we can use the same rule again. So like we did before, we're saying, oh, what, n plus 1, and if we have a number factorial, we can split up into the number times a number minus 1 factorial. So it turns out here, that's really useful, because now we can just say x plus 1, and then x plus 1 minus 1, that's just x factorial. Oh look, we've got an x factorial on that side. Yo, no way, we can probably just cancel them, which we can, because as we pointed out earlier, because of this nice looking equation thing. Actually, it looks disgusting, but it's really nice. It means we know we can cancel factorials without any problems, because we know that regardless of the input, we're going to get a non-zero output. So that's really nice, because even 0 gives 1. Okay, so yeah, we can just cancel that. We're mathematicians, we don't care. Okay, let's cancel it in the most dramatic fashion possible. Yep, very cool. Okay, what are we left with? No factorials somehow. I don't know how this happened, but it did. Well, x plus 1 equals n minus x. Whoa, look, we connected x and n. Let's make n the subject just because we want a fancy looking answer. And there we go. That's pretty cool, I think. Pretty fun problem. And it makes this formula actually useful, even though it looks completely not useful. It allowed us to solve a problem we wouldn't be able to otherwise. So yeah, we did what the question asked for. We linked x and n. Yay. Alright. Do people want an explanation of 0 factorial equals 1? It's not as advanced as it would seem. Like, I saw this recently and I was like, oh my goodness, why? Whose idea was this? But then someone showed me a proof for it and it was so simple that my mind was blown. But then if people have already seen it, then it's kind of boring. Maybe I'll just do it anyway. And then if everyone starts saying, no, I've seen it before, and it's like, oh, sometimes. Alright, let's do it. So, question. I'm not going to write this out. Oh, I am, because I can do this. Haha. Why the heck is 0 factorial equals 1, bro? Okay. Pretty good question. Let's answer it. So, in order to do this, we need to redefine what we think by factorial. And this turns out, as a mathematician, this is pretty much the way they all like to think about factorial. So, the sort of like, I have no idea what I'm doing definition of factorial is just, you look at it and you're like, oh, it's just 5 times 4 times 3 times 2 times 1. So it would seem like that's how we would define factorial, right? It's just you keep subtracting by 1 and multiplying until you get to the end. And that's one way of thinking about it. But it turns out mathematicians prefer another way to think about it, which is pretty crazy, but I'll show you how I would do it. So I'll do it in purple. So let's use 3 factorial as an example to look at the alternate view of looking at what factorial is. Basically, the way they'd look at it is they'd think about it as they're asking, if we had 3 items in a set, how many different ways are there of arranging those items? So we've got a set. Let's say we just call the items A, B, C, because I think that's probably the clearest way to think about it. And it's basically asking how many different ways are there of arranging A, B, C. So do this systematically. We'll start with A. And the 2 ways we can have A after, the other 2 items after A is A, B, C. Have A, C, B. Put another one in front. Do C, A, B. Followed by, we could just swap them, C, B, A. And it seems like this pattern's just going to continue actually. So then we'll do B at the start because we haven't done that yet. AC. And then we'll do BCA. It doesn't seem like there's any other ways of doing it because we put all the things at the start we could have. And whenever you put one at the start, there's only two other ways those can combine. And yeah, sure enough, those are all the ways you can combine 3 items. So how many ways are there here? Well, there's 1, 2, 3, 4, 5, 6. Oh, look. So basically, factorial will tell you how many ways you can arrange a set of items without having to actually do anything, which is pretty neat. It does a few other things, like it allows you to write more complex equations without as much difficulty because you got this notation. But so if we had 2 factorial, well, we know using this rule, well, let's say we got A and B. How many ways are there of arranging the set of A and B? Well, there's this way, A and B, and there's only one other way, really, which is BA. 2 factorial equals 2. What about 1 factorial? We've got 1 item. Let's draw a creeper because I feel like it's going to be the worst drawing of a creeper ever. How many different ways are there of arranging this guy? Oh, I need to draw set brackets around it. There we go. How many ways are there arranging of just 1 item? Answer, well, there's only one way. How else do you arrange the item other than this? That's it. So 1 factorial equals 1 because there's one way of arranging 1 items. Okay. What about our old friend 0 factorial, hey? How many ways are there arranging 0 items? Well, if we imagine a set of 0 items, how many ways are there arranging that set? Oh, there's one way of arranging that set. Hence, 0 factorial equals 1. There's your proof. It's not even that advanced. It's pretty crazy, actually. But yeah. Fun times. It turns out this is really useful. It doesn't seem like it should be useful, but then it is, because if we go back to Pascal's triangle, like it would seem, because what's crazy, remember, is as I said earlier, we've got our n values here, and then we've got our r values here. And what's crazy is that we could just look at it and be like, for example, the NCR, if we need 2C1, and we can look at this to find it. But then what's crazy is we can also use the formula n factorial over r factorial. So what it means is that Pascal's triangle is this, basically. Which is pretty crazy to think about, really. Like, whoever came up with this is crazy. So, these two things that just look unbelievably different are the same thing. Oh my goodness. So yeah, so what it means is that, what does it mean? What we want for Pascal's triangle is it doesn't matter what value you put in here, whether it's 99 or 7, or we want 0 here. We want this to give 1 because we know the 0th item of every single row of Pascal's triangle should give 1. So when we throw this into the formula, this is n, this is r, we get 99 factorial which is going to be a pretty big number, but then 0 factorial. Wait, what? Oh yeah. So if 0 factorial didn't work, then it would be a problem, but you see, because 0 factorial just equals out to be 1, it means that our equation works really nicely in terms of this 1 structure going there. So it turns out mathematicians defining 0 factorial is actually useful. It doesn't look useful, but then it is. So I guess that's why they did it. But also because 0 items, how many ways of arranging it? 1. So yeah, I think that's it for me. I'm completely out of ideas. Bro, this is meant to be a quick study of binomial expansion. I pretty much covered everything. I can't believe I did anything. What? I was meant to be playing, I don't even know. Was that enjoyable? Was that a thing? I don't know. Let me know what you guys think. Or has everyone just left? Oh well. I'm not complaining. Guess I'll end the stream there, maybe. Alright, well that was math. Yay. Yeah. Alright. I don't know what to do anymore. That's pretty fun. I can't believe that worked and stuff. Okay. What? That's doing fun things. Okay. Yeah, I guess I'll end the stream there. Yeah, I'm exhausted. The thing is I was like, oh, it would be so cool to actually make a video after like not making a video for forever. So today I was like, I don't even care how tired I am, I'm just gonna make a video. But maybe a bad idea. I don't know. That was fun. I can't believe I did that though. I thought I was just gonna be playing Chuckie Egg really late because I felt like it. All right. Oh, we still need to play tennis, by the way. You need to destroy me at tennis. Oh, that would be funny. Yeah. Okay. See you in a bit then. Bye.